So one of the things that we can do with an alternating series is we can get a pretty good approximation of its sum, at least in the case where the alternating series is formed by some underlying positive decreasing sequence. So once again, let's define an to be a positive decreasing sequence for n greater than or equal to 1. And just recall that what decreasing means is that an plus 1 is less than an. So every time I get to the next term in the sequence, it's less than the previous term, but we're still requiring the terms to be positive, so they may decrease asymptotically to 0, let's say, or to some other number, but they are decreasing. So let's prove that, let's use that fact to prove that that the sum of s, which I've defined here as just that's the infinite sum, a1 minus a2 plus a3 minus a4 plus a5 minus a6, etc. Let's prove that that sum is between 0 and the first term a1. And understand, this is not generally true for series. It's only true for an alternating series that's formed in this way. So the argument goes something like this. If I write out s like this, right, a1 minus a2 plus a3 minus a4 plus a5 minus a6, that's as far as we need to go. I can group the terms in this way. And the thing to notice here is that each of these terms in parentheses is positive. Now why? That's because the series is decreasing, the sequence is decreasing. So a2 is less than a1, which means that a1 minus a2 is going to be a positive number. If I take a smaller number and subtract it from a larger number, I get a positive number. And of course, we're requiring that all these terms be positive, so we don't have to worry about kind of the mirror image of that situation where some of these terms might be negative. Although we're putting a minus sign in front of a2, a2 itself is still a positive number. So, okay, so that's positive, and that's positive, and that's positive. So when I take all of these together, what you can see is that I'm taking a whole bunch of positive numbers and adding them together, which means that I can only get something that's greater than 0. So that takes care of this part. So let's do do the other part, which is showing that it's less than a1. All we have to do is just group the terms together slightly differently. Let's write a1. Let me just do that. We'll just grab this. Not sure if this is actually going to be faster. There we go. So we have this again, and by the way, I should have written here ... because this actually does go on forever. But if what I do here instead is let me put parentheses around these like that. But since the minus sign distributes, that means that in order to have it to have the same meaning, in other words, I'm supposed to be adding a3, not subtracting it. That means I have to subtract negative a3. So this becomes a minus sign, and this becomes a minus sign again in order to equal this expression. Because now I have minus a2, which is correct, and then minus negative a3, which gives me the same as this plus a3 here, and it goes on like that. So once again, these pairs are still positive because I'm still subtracting a smaller number from a larger number, and I would be doing the same thing here. I just haven't written an a7 term. In fact, then I would have to change this to a minus sign. So this now becomes a1 minus a bunch of positive terms. So it certainly stands to reason that if I take a1 and subtract a bunch of things that are positive, I'm going to get a number that's less than a1. So I put together the fact that s is greater than 0 and less than a1, and I write it together as a single inequality, and that gives me that s is going to be less than a1 but greater than 0. And this is kind of a nice fact because what it means is that the sum of the series has to lie somewhere between 0 and its first term. That's just how that works, and it's fairly nice because what you know is that even if you don't know what the sum of the series is, and we've often seen that we can often prove a series converges, but we don't know what it converges to. Here we can find kind of a nice tight bound on what the sum could be, somewhere between 0 and a1.